guys, Nicole here with another tutorial. This time we're going to be talking about fractional numbers. This one should be a pretty quick tutorial. I am going to show you today how to take this fractional number 392.625 and we're going to put base 10 behind it right here because I forgot to put that. And we're going to convert this to binary. Believe it or not, yeah, that's right, binary. So how do we convert this number to binary? And again, and once you do that, and this is important because when we get into things like floating point format, where there's 20, if you have single point precision, like a 32F floating point format with single precision value, there's going to be 23 fractional bits in there. But so before we get into that kind of craziness, we need to know how to actually deal with those in binary, because like, what do we do? So, because everything up to this point has been whole numbers, right? So that's what this tutorial is all about today. So let's get started. All right, so what are we going to do? So the first thing we're going to do here today is I'm going to start with the whole number. That's the easiest thing to start with. So I'm going to convert that number to a binary value. So to do that, just like we've been doing all along, I'm just going to write my number over here. So I'll say 392, and it's base 10. So I'm going to put the base 10 by it. And we're just going to write our little scale. Now, I kept the little boxes off this time. I'm just going to write it out and do my best to keep it in as clean as I possibly can. This is a quick tutorial, so 1632, making sure I don't miss a number. And I'm also going to put a little line here so I know 64, 128, and then 256. There we go. You guys will be seeing this in your sleep probably before long. So there's our values there. So we start again. I can't go any higher because the next number up is 512. That's bigger than 392. 256 does go into 392. So again, 392. Subtract that 256 from it and take the difference, which is, I should have this memorized at this point. Let's see. That's going to be 8, 12, 6. You guys are probably like, again, really? So 136. 128 does go into 136, leaving 8 left over. And then we got 0, 0, 0, 1, 000. I won't bore you guys to death with the process. So there we go. And again, base 2. So that's our convert. So that's our whole number. I'm just gonna leave that over there on that side. So that's our. In fact, I'm gonna write this up like this. I'm gonna say this is our whole number. Whole number. Now, if you're like me, I know when I was in school, I always hated fractions. So when I first saw this for the first time, I was like, it was a little intimidating, but it's actually not as bad as it might sound, right? So now what do we do with this 625? Like, how do we get that to a binary number? Well, so what we're going to do here is we're going to take the 0.625 part, so 0.625, and because it's a binary number, we want to convert this to binary, I should say. What we're going to do is we're going to multiply by 2. Now, how far do we go here? Our goal is to get to 1.00. That if we see this value as a product of our work, we stop. So let's start. So again, that's what we're looking for. So the first value here is 5 times 2 is 10. So we got a 0, carry the 1. That's 5. 12. Carry the 1. 0 times 2 is 0. Plus 1 is 1. We're going to move the decimal place 3 places to the left. Gives us 1.25. And this right here, oops. Let's do it this way. I'm going to color code it. I'm going to get all fancy. Becomes our first digit. So the very first binary value is right there. That's our first binary bit. Right. So the first bit is 1 in this case. So I'm going to put a 1 over here. That's what we do. Now what we do is I'm going to come in here with my little eraser. Oops. Try that one more time. Oops. So 0.25. Actually, before I erase that, let's do this. So the next value I'm going to figure out is I'm going to get rid of the 1. So the 1 just came over here. So imagine that's gone. So now what I'm going to do is I'm going to take 0.25. We're going to multiply that by 2. And then I'll get rid of all this here in a sec. So 0 times 2 is 0. 5 times 2 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. decimal, and then 0 times 2 is 0. So yeah, there we go. So you can see, so there we go. Just double check that. So 3 places at the left, yeah, so 0.5. So our next bit is 0. That's our next binary bit. So I'm gonna write that over here, just like that. So we're left with 0.5. So 0.5 is our next number. So now I'm gonna do some erasing here, just to clean up house. So 0.5 is our next number. Again, we're gonna multiply this by 2, like this. 5 times 2 is 10. Carry the 1. 0 times 2 is 0, plus 1 is 1. And here we go. So now what that gives us is our last bit, which is a 1. And we stop here because we're at 1.0. So we've reached the end of the journey, essentially. So essentially, this will be this 101 base 2, that is what that's how we represent 625, the fractional bits 625. So what we'd end up with something like this. We'd have 1 1 0 0 1 0 0 decimal 101 in binary. So pretty cool, right? So that's how we get it. So now let's say we want to go back. So we want to convert that back. Now how does that work? What do we do there? So well, this works. So let's just clean this up a little bit here. So we're just gonna get back to there. Get rid of some of this over here. Boop, just like that. All right. So I'm gonna rewrite this up here. So this number is 1 1 0 0 1 0 0 decimal 101 sub 2, and there we go. Okay, so that's our value right there. So now how do we go back? Well, this part's the easy part. So we already know that that's 392. So we just do our conversion. I won't bore you with that part. So again, we already know that that's 1 2 4 8 16 32 64 128 256 and 256 over here. Right, so we know that part, so that's our value there. So that gives us the whole number of 392. I won't bore you with that because you guys have seen me do it 1,000 times already. now this part right here, so I'm going to bring this down just like this. I'm actually going to rewrite this like this, 101. What exactly is this here? Well, think of it like this. So this is going to be 2 to the negative 1. This is 2 to the negative 2. And this is 2 to the negative 3. Now, anybody that's familiar with exponents probably knows where I'm going with this. Whenever you have the negative exponent, it gives us the inverse, the reciprocal, to get back to actually get our value. So what does that mean? What I mean by that is this 2 to the negative 1, it's to actually get its reciprocal. It's going to actually it equates to this. So it's going to be 1 over 2 to the positive power 1. So that gets us back to this. Over here, we have 1 over 2 squared. So you can see we got that right there. And then this number right here is going to be 1 over 2 to the third power. So essentially this is going to be, so this is going to be 1 divided by 2. I don't know if I'm going to rewrite this like this. 1 divided by 2. This will be 1 divided by 4. And then this is going to be 1 divided by 8. And you can actually see there's a little bit of a trend here. So 2, 4, 8. So you can kind of see the way we're going here, right? So so this first bit, 1 over 2, if we divide that, 2 can't go into 1, equals 1. Bring the 0 down like this. 5 times 2 equals 10. So essentially this is 0.5 over here. This one here. Now some of you may be familiar with this already. I'm just doing this just to show the process. I realize this might be, so if this is boring to you, skip ahead. 1 divided by 4. 4 can't go into 1, so we're going to put a 0 here. Take the difference, that's 1. Decimal 0, bring the 0 down. So that's going to be 2. 2 times 4 is 8. Take the difference, that gives us 2. bring the 0 down over here. 5 times 4 is 20. Subtract the difference, gets us to 0. So this position is worth 0.25. And then lastly, we have one more position. So this is going to be our 1 over 8. Again, 8 can't go into 1, so we're going to put a 0 here. Decimal 0. Funny computer, sometimes it does stuff like that. All right, so we got, oops. 1 times 8 is 8. 2, 0. Bring this little 0 down here. Try and make that look like an actual 0. That's where I go wrong. That's exactly where I go wrong right there. Start doing chicken scratch. 2 times 8 is 16. That's 4. Just checking my work because it's late. 0, bring the last 0 down. That's 40. 8 goes into 45 times. 5 times 8 is 40. Take the difference, gives us 0. So what we get there is 0.125. 0.125. And all we do with this now is we just add the values that have a 1 in them. So essentially, we're going to add this value and this value. So what we're going to do is we're going to add 0.5. And I'll put some zeros here just to make it easier to see. Plus, we're not going to add this because that's going to be 0. Right? And then we are going to add the 0.125. So that's going to be 0.125. And when we add these together, what do we get? 2 and 6. How cool is that? So that is how we do fractional number. Now this is going to be really, really important down the road because in a later tutorial when we're talking about, like I said before, we're talking about floating point formats, or even resolutions. And the thing to remember about this is the more fractional bits you have, like if we were to add like a whole bunch more bits over here, like we just kept adding a bunch of 1s and 0s to the right, the more we add to the right, the higher the degree of precision we get. So you will see that with fractional digits, right? So, but it's kind of a trade-off, right? So the more bits we add, the more disk space we start to take up in file size and things like that. So it's kind of a trade-off, like how much precision do you want, but also how much file size do you want to take up with your actual samples. Like, so for example, just to give you an example, 32 floating point format has 23 fractional bits. So and that's single point precision compared with, I want to say there's like 50 some fractional bits for double precision. So like I want to say it's up in the 50s. So that's the difference. Like, so when it comes to these kind of things, the more fractional bits you get, the more precision. So, but hope you guys learned something from this tutorial. And I will see you on the next one. Happy Thursday. Practice, practice, practice. And we'll see you on the next one. Toodles.